T216B CCNA 4 Connecting Networks, Chapter number 7, Securing Site-to-Site Connectivity. In this chapter, we are going to talk about the virtual private networks or VPNs, site-to-site GRE tunnels, introducing the IPsec, remote access, and we will end up the session with a summary. The main objectives of chapter 7 are: we are going to talk about the benefits of a virtual private network technology. We will describe a site-to-site and remote access VPN, the purpose and benefits of GRE tunnels, how to configure a site-to-site GRE tunnel, the main characteristics of IPsec, how IPsec is implemented using the IPsec protocol framework. We'll talk about how the AnyConnect client and clientless SSL remote access VPN implementations support business requirements. We will compare IPsec and SSL remote access VPNs. Further to that, security is a concern when using the public internet to conduct businesses. VPNs or virtual private networks are used to ensure the security of data across the internet. A VPN is used to create a private tunnel over a public network. Data can be secured by using encryption in this tunnel through the internet and by using authentication to protect data from unauthorized access. Finally, this chapter explains the concept and processes which are related to VPNs, as well as the benefits of implementing the VPN and the underlying protocols which are required to configure the virtual private networks. VPN. Introducing virtual private networks. Virtual private networks or VPNs are used to create an end-to-end private network connection over third-party networks such as the internet or extranets. In order to implement a VPN gateway is necessary. It could be a router, it could be a firewall, or Cisco Adaptive Security Appliance ASA. Benefits of VPN: cost saving. It enables the organizations to use cost-effective third-party internet transport to connect remote offices and remote users to the main site. Scalability. It enables organizations to use the internet infrastructure within the ISPs and devices, which makes it easy to add new users. Further, compatibility with broadband technology. It allows mobile workers and telecommuters to take advantage of high-speed broadband connectivity such as DSL and cable to gain access to the networks of their organization by providing workers flexibility and efficiency. It also provides a cost-effective solution for connecting remote offices. Security is one of the main features of VPN. Security can include different security mechanisms that provide the highest level of security by using advanced encryption and authentication protocols that protect the data from unauthorized access. There are different types of VPN. Site-to-site VPN is one of them. Site-to-site VPN connect the entire networks to each other. In the past, a lease line or frame relay connection was required to connect site, but because most corporations now have internet access, these connections can be replaced with site-to-site VPNs. Internal hosts have no knowledge that a VPN exists. Site-to-site VPN created when devices on both sides of the VPN connections are aware of the VPN configuration in advance. Also, the end hosts send and receive normal TCP/IP traffic through a VPN gateway. The VPN gateway is responsible for encapsulating and encrypting outbound traffic for all traffic from a particular site. The VPN gateway then sends it through a VPN tunnel over the internet to a peer VPN gateway at the target site. Upon receipt, the peer VPN gateway strips the headers, decrypts the content, and relay the packet towards the target host inside its private network. This is how the site-to-site VPN works. Another type of a VPN is a remote access VPN, which basically supports the need of telecommuters, mobile users, and extranet consumers to business traffic. Remote access VPN supports a client-server architecture where the VPN client or a remote host gains secure access to the enterprise network via a VPN server device at the network edge, used to connect individual hosts that must access their company network securely over the internet. Remote access VPN client software may need to be installed on the mobile user's end device. Cisco AnyConnect Secure Mobility Client is one of the software. Also, the remote access VPN are used when the host tries to send any traffic. The VPN client software encapsulates and encrypts this traffic and sends over the internet to the VPN gateway at the edge of target network. This is how the remote access VPN works. How does a remote client initiate the VPN connections to the VPN terminating device through the internet? Site-to-site GRE tunnels. The fundamentals of generic routing encapsulation by introducing to GRE, which is basic non-secure site-to-site VPN tunneling protocol developed by Cisco. It encapsulates a wide variety of protocol packet type inside the IP tunnels. It creates a virtual point-to-point link to routers at remote points over an IP internetwork. These are some of the characteristics of the GRE. GRE header contains different information such as IP, and then a special field which is a GRE, which includes flags and protocol type. And the main responsibility of these fields in the GRE protocol is to identify the flags, which identify the presence of optional header fields, and protocol type identifies the type of payload. Ether type 0 multiplied by 800 is used for IP version 4. Some of the main characteristics of the GRE. GRE is defined as Internet Engineering Task Force or IETF standard. IP protocol 47 is used to identify GRE packets. GRE encapsulation uses protocol type field in the GRE header to support the encapsulation of any OSI layer 3 protocol. GRE is a stateless protocol. It does not include any flow control mechanism by default. GRE does not include any strong security mechanism to protect its payload. The GRE header, together with the tunneling IP header, creates at least 24 bytes of additional overhead for tunneled packets. This is how the GRE tunnel configuration. On router 1, by issuing the basic commands such as interface and then tunnel, we have to give the tunnel, like in this example, tunnel 0, and then tunnel mode GRE IP, and then IP address, and we have to mention the IP address, and then we have to give the command tunnel source, then we have to give the command tunnel destination, mention the area, router OSPF1, and network by giving the network number, which is the IP address and subnet mask with the area 0. These are the basic GRE tunnel commands. Tunnel mode GRE IP. This command specifies the GRE tunnel mode as the tunnel interface mode in interface tunnel configuration mode. Tunnel source, then IP address, specifies the tunnel source IP address in interface tunnel configuration mode. Tunnel destination and then IP address specifies the tunnel destination IP address in interface tunnel configuration mode. IP address and then IP address mask specify the IP address of the tunnel interface. In order to verify the GRE tunnel, we can issue a command such as show IP interface brief, which includes the tunnel. This will verify the tunnel interface, which in this example is up, by issuing the command show interface tunnel 0. So tunnel 0 is up and line protocol is up, and then the internet address is there, tunnel source address, tunnel destination address, and tunnel protocol. In order to verify the OSPF adjacency, we can issue a command on a router console by show IP OSPF neighbor. Introducing IPsec. IPsec is a short form for Internet Protocol Security. IPsec VPNs. Information from a private network is securely transported over a public network. IPsec VPNs form a virtual network instead of using a dedicated layer 2 connection. IPsec VPN to remain private, the traffic is encrypted to keep the data confidential. The major functionalities of IPsec. IPsec defines how a VPN can be configured in a secure manner using the Internet Protocol. It's a framework of open standards that spells out the rules for secure communications. IPsec not bound to any specific encryption, authentication, security algorithms, or keying technology. IPsec relies on existing algorithms to implement secure communications. IPsec works at the network layer, protecting and authenticating IP packets between participating IPsec devices. IPsec secures a path between a pair of gateways, a pair of hosts, or a gateway and host. All implementations of IPsec have a plain text layer 3 header, so there are no issues with routing. IPsec functions over all layer 2 protocols such as Ethernet, ATM, or frame relay. IPsec characteristics. IPsec characteristics can be summarized as: IPsec is a framework of open standards that is algorithm independent. IPsec provides data confidentiality, data integrity, and origin authentication. IPsec acts at the network layer, protecting and authenticating IP packets. IPsec security services. Confidentiality, encryption. IPsec encrypts the data before transmitting it to across the network. IPsec provides data integrity by verifying that data has not been changed while in a transit. If tampering is detected, the packet is dropped. Authentication, which verifies the identity of the source of the data that is set, ensures that connection is made with the desired communication partner. IPsec uses IKE, which is the Internet Key Exchange, to authenticate users and devices that can carry out communication independently. Also, it supports anti-replay protection, which detects and rejects replayed packets and helps prevent spoofing. So IPsecs basically provide confidentiality, integrity, and authentication. Confidentiality with encryption. For encryption to work, both the sender and receiver must know the rules used to transform the original message into its form. Rules are based on algorithms and associated keys. Decryption is extremely difficult or impossible without the correct key. Encryption algorithms. As key length increases, it becomes more difficult to break the encryption. However, a longer key requires more processor resources when encrypting and decrypting data. The two main types of encryptions are symmetric encryption and asymmetric encryption. In a symmetric encryption, both encryption and decryption processes uses the same key. Each of the two networking devices must know the key to decode the information, and each device encrypts the information before sending it over the network to the other device. Symmetric encryption typically used to encrypt the content of the message Some of the examples of the symmetric encryption are DES or 3DES, which is no longer considered secured, and AES, which is a 256-bit recommended for IPsec encryption. Asymmetric encryption is basically uses two different keys for encryption and decryption of data. In asymmetric encryption, knowing one of the key does not allow a hacker to deduce the second key and decode the information. In an asymmetric encryption, one key used to encrypt the message, while a second key is used to decrypt the message. Public key encryption is a variant of asymmetric encryption that uses a combination of a private key and a public key. Asymmetric encryption typically used in digital certification and key management. One major example is RSA. Diffie-Hellman key exchange, or DH, is not an encryption mechanism, and it is not typically used to encrypt data. Diffie-Hellman is a method to securely exchange the keys that encrypt data. Diffie-Hellman algorithms allow two parties to establish a shared secret key used by encryption and hash algorithms. DH is a part of the IPsec standard. Encryption algorithms such as DES, 3DES, and AES, as well as the MD5 and secure hash algorithm 1 hashing algorithms require a symmetric shared secret key to perform encryption and decryption. Diffie-Hellman algorithm specifies a public key exchange method that provides a way for two peers to establish a shared secret key that only they know, although they are communicating over an insecure channel. This example shows how the Diffie-Hellman key exchange took place between a sender and receiver. IPsec framework integrity with hash algorithms. The original sender generates a hash of the message and sends it with the message itself. The recipient parses the message, and the hash produces another hash from the received message and compares the two hashes. If they are the same, the recipient can be reasonably sure of the integrity of the original message. Integrity with hash algorithms example. Sender and receiver, how they are using an integrity framework by exchanging the key among each other. Hash message or hash based message authentication code HMAC is a mechanism for message authentication using hashing functions. Hash based message authentication has two parameters: a message input and a secret key known only to the message originator and intended receivers. Message sender uses an HMAC function to produce a value, the message authentication code, formed by condensing the secret key and the message input. Message authentication code is sent along with the message. Receiver computes the message authentication code on the received message using the same key and the hash based message authentication function as the sender used. Then receiver compares the result that is computed with the received message authentication code. If the two values matches, the message has been correctly received and the receiver is assured that the sender is a user community member who shared the key. There are two common HMAC algorithms. MD5 is one of them, which uses a 128-bit shared secret key. The variable length message and 128-bit shared secret key are combined and run through the HMAC MD5 hash algorithm. The output is 128-bit hash. The hash is appended to the original message and forwarded to the remote end. SHA, which is a secure hash algorithm, SHA1 uses a 160-bit secret key. The variable length message and the 160-bit shared secret key are combined and run through the HMAC SHA1 hash algorithm. The output is 160-bit hash. The hash is appended to the original message and forwarded to the remote end. IPsec authentication. IPsec VPN also supports authentication. The devices on the other end of the VPN tunnel must be authenticated before the communication path is considered secure, which is a peer authentication between remote office and a corporate office. There are two peer authentication methods. One is a pre-shared key PSK and RSA signatures. PSK is a secret key which is shared between the two parties using a secure channel before it needs to be used. It uses symmetric key cryptographic algorithms. A pre-shared key is entered into each pair manually and is used to authenticate the pair. RSA signatures are digital certificates which are exchanged to authenticate the peers. Local device drivers a hash and encrypts it with its private key. Encrypted hash or digital signature is attached to the message and forwarded to the remote end. At the remote end, the encrypted hash is decrypted using the public key of the local end. If the decrypted hash matches the recommended hash, the signature is genuine. Authentication header AH. Appropriate protocol to use when confidentiality is not required or permitted. Authentication header provides data authentication and integrity for IP packets that are passed between the two systems. Authentication headers does not provide data confidentiality or encryption of packets. ESP or encapsulating security payload. It's a security protocol that provides confidentiality and authentication by encrypting the IP packet. ESP authenticates the inner IP packet and ESP header. Both encryption and authentication are optional in encapsulating security payload. At a minimum, one of them must be selected. This is how the IPsec protocol authentication header communicate with its peer by providing authentication and integrity, and encapsulating security payload provides encryption, authentication, and integrity. There are four basic building blocks of IPsec framework that must be selected. First is IPsec framework protocol, which is a combination of ESP and AH authentication header. ESP or ESP plus authentication headers options are almost always selected because authentication header itself does not provide encryption. Number 2, confidentiality. If IPsec is implemented with ESP-DES or 3DES or AES, AES is strongly recommended since it provides the greatest security. Number 3 is integrity, which guarantees that the content has not been altered in transit using the hash algorithms by using MD5 or SHA. Number 4 is authentication. This represents how devices on either end of the VPN tunnel are authenticated by using PSK or RSA. Number 5 is DH algorithm group, Diffie-Hellman algorithm group, which represents how a shared secret key established between peers. DH24 provides the greatest security. This is how the IP protocol framework works at the, we have Diffie-Hellman, authentication, integrity, confidentiality, and that's the IPsec protocol. Remote access. Remote access VPN solutions. There are different types of remote access VPNs. Two primary methods for deploying the remote access VPNs are SSL, which is a secure socket layer, and IPsec, Internet Protocol Security. Type of VPN method based on the access requirements of the users and the organization's IT processes. Both type offers access to virtually any network application or resource. Cisco SSL VPN. Cisco SSL VPN provides remote access by using a web browser and the web browser's native SSL encryption. Cisco SSL VPN can provide remote access using the Cisco AnyConnect secure mobility client software. Cisco SSL VPN solutions. Cisco AnyConnect secure mobility client with SSL. It is a client-based SSL VPN which provides authenticated users with LAN-like full network access to corporate resources. The remote devices require a client application such as the Cisco VPN client or the newer AnyConnect client to be installed on the end user device. Cisco Secure Mobility Clientless SSL VPN, which enables corporations to provide access to corporate resources even when the remote device is not corporately managed. Cisco Adaptive Security Appliance ASA is used as proxy device to network resources, which provides a web portal interface for remote devices to navigate the network using port forwarding capabilities. IPsec for remote access. Cisco EasyVPN, which basically negotiates the tunnel parameters, establish tunnels according to the set parameters, authenticate users by usernames, group members, and passwords, manage security keys for encryption and decryption, authenticates, encrypts, and decrypts data through the tunnel. The Cisco EasyVPN solution consists of three components. Number one, Cisco EasyVPN server, which is a Cisco iOS router or Cisco ASA firewall acting as the VPN head and device in site-to-site or remote access VPN. Number two, Cisco EasyVPN remote, a Cisco iOS router or Cisco ASA firewall acting as a remote VPN client. Number three, Cisco VPN client, an application supported on a personal computer used to access a Cisco VPN server. The Cisco EasyVPN solution features offers flexibility, scalability, and ease of use for both site-to-site and remote access IPsec virtual private networks. This is how Cisco EasyVPN server and remote users they are communicating with each other. Comparing IPsec and SSL. When it comes to the applications, SSL, web-enabled applications, file sharing, and email. And IPsec supports all IP-based applications. Encryption, SSL supports moderate to strong key length from 40 bits to 256 bits. IPsec's key length from 56 bits to 256 bits. When it comes to authentication, SSL supports the moderate one-way or two-way authentication, and IPsec supports strong authentication by providing two-way authentication using shared secrets or digital certificates. Connection complexity, low in SSL, require only a web browser. IPsec supports medium, can be challenging to non-technical users. Connection options in SSL, any device can connect, but in case of IPsec, only specific devices with specific configurations can connect. Chapter 7 Summary. In this chapter, we discuss the different concepts of VPN, how VPNs are used to create a secure end-to-end private network connection over a third-party network, such as the internet. A site-to-site VPN uses a VPN gateway device at the edge of both sites. The end hosts are unaware of the VPN and have no additional supporting software. We talked about a remote access VPN, which requires software to be installed on the individual host devices that accesses the network from a remote location. The two major types of remote access VPNs are SSL and IPsec. SSL technology can provide remote access using client's web browser and the browser's native SSL encryption. Using Cisco AnyConnect software on the client, users can have LAN-like full network access using secure socket layer. GRE is a basic, non-secure, site-to-site VPN tunneling protocol that can encapsulate a wide variety of protocol packet types inside IP tunnels, thus allowing an organization to deliver other protocols through an IP-based WAN. Today it is primarily used to deliver IP multicast traffic or IP6 traffic over an IP4 unicast only connection. IPsec is an Internet Engineering Task Force standard which provides a secure tunnel operating at layer 3 of the OSI model and can protect and authenticate the IP packets between IPsec peers. Moreover, it can provide confidentiality by using encryption, data integrity, authentication, and anti-replay protection. Data integrity is provided by using a hash algorithm such as MD5 or secure hashing algorithm SHA. Authentication is provided by the pre-share key or RSA peer authentication method. The level of confidentiality provided by encryption, it depends on the algorithm which is used and the length of the key. Encryption can be symmetric or asymmetric. Diffie-Hellman is a method which is used to securely exchange the keys to encrypt data. Thank you for watching.